Now there's this series 1 over n, and then natural log of n is squared. So the idea is 1 over n, that would diverge. By having this extra natural log of n squared in there, is that adding enough to the denominator so that the total will be very small fractions that add up to a finite amount? Well, let's see. We could use, let's say we try the ratio test. If you try the ratio test, you're going to end up with something like this. And then, how do you simplify something like that? Well, there's no rules for simplifying natural log of two things being added together, so there's not much we could do with that. If this was a product, natural log of n times something, then there's rules for that. But with this, no. What else? Well, we could try a comparison and say, well, maybe this is sort of like having n squared and then n. So maybe this series is like this series, which converges. But the thing is, I'm saying natural log of n is approximately equal to n. Is n approximately equal to the natural log of n? So if you had 1,000, is that approximately the same as the natural log of 1,000? I don't think so. So you have natural log of 1,000. No, that's only 6.9. That's not approximately equal to the original 1,000. So those ideas aren't working out. But this is how it goes with trying to figure out if a series converges or not. Maybe we could integrate. Let's try the integral test. So if you integrate 1 over n and then natural log of n squared with respect to n, this one goes from 2 to infinity. Then use u substitution. You should always try u substitution first whenever integrating. And I'll let u equal the inside part, which is the natural log function. The derivative of that is 1 over n dn. Oops, I'm so used to putting x. dn. And then that's exactly what we have right here, dn and 1 over n. So the u substitution is perfect. So that's going to be integrate, and for now I'll leave the limits off until I get the n's back. It's going to be 1 over u squared for that part, and then this other part is the du. So in other words, integrate u to the negative 2. Well, that's going to be u to the negative 1 over negative 1. Or in other words, negative 1 over u. And u is this guy. Alright, now that it's back to n, I'll put the limits. It goes from 2 to infinity. So it's going to be negative 1 over the natural log of infinity minus the negative 1 over the natural log of 2. So this is a positive finite number, not very big, and this natural log of infinity is infinity. 1 divided by infinity is 0. So the final answer is that it's 1 over the natural log of 2, which is a finite number, so it converges by the integral test.